Hey guys, welcome back. We are going to be continuing similarity. Now, I said in the last video that we're going to do area and volume. I may have lied about that. There's a bit more to do, realized, for this topic for similarity and length. Parallel lines and triangles in triangles. So let's look at some examples here. We have actually gone through this in year 10. I have shown you variations of this slide, but I just want to recap it with you. So some questions on similarity will have triangles around parallel lines. So you can see here, there's parallel line there. So X, Y, B, C. In both cases, B, C, X, Y, they're parallel to each other. And you can see there are triangles that form inside each. You're going to need to know that these triangles are similar to each other. And I've got a little animation to show you. So let's break it down here. So with the triangle on the left, you can see that this angle here is going to match that angle there, and that angle there is going to match. Let's use the letters. ABC is equal to angle AXY. And we can also say AYX is equal to ACB. And for this shape here, using angles in parallel lines, corresponding and alternate angles, in this case, we can say that this angle, let's say BYX, which is this angle here, is equal to CBY, which is that angle up there. So I've just colored them in here so you can have a look. The corresponding angles are the correct color. If you're colorblind, then I'm really sorry. I can't really help you there. Now, if you look at the shape on the top, because they're those corresponding angles, when you are given a shape like this, you have to imagine that you are splitting this up into that triangle there and that triangle there, and then it just becomes a simple similar triangles question. Or for a shape like this, you have to imagine that this triangle here, if you take that out, and the bottom triangle, if you take that one out. Now, if I turn this upside down or rotate it, you can see they actually match as well. And that way you can actually then work out corresponding sides or length, and we'll do some examples of that now. So in this case, we're asked to work out length X. So I know that in terms of similar triangles, if I redraw this the right way around, or what feels like the right way around, so this would be X, this would be 6, and 9 would be the base. And then the triangle on the bottom stays the same. So you have Y, you have 6, and you have 10. You can then work out the scale factors. So to go from 6 to 10, the scale factor is, well, I multiply by 10 and I divide by 6, so 10 over 6. That can simplify to 5 over 3. This is the scale factor. And then I can say, well, how can I find X? Well, I'm going to go the other way around. So 6 divided by 5 over 3, which will give me 18 over 5, or 3.6. And then in this case, I want to go from 9 to Y. So I'm going to do 9 times 5 over 3. So 9 times 5 divided by 3 is going to give me 15 centimeters. So it's one of the ways that we can work out missing lengths. In this case, we didn't really have to look at angles, but angles will come into play at some other points. Now, there's an example here that works through a question, so I'm not going to go through it. You can pause the video and read it in your own time. Very similar to what we've been doing. And exercise 5 and 6 is optional. I'm actually going to say you don't need to do that, so let's leave that. Now, let's look at some harder problems. In the diagram, BCD is a similar triangle to ACE. Work out the length of BD. So we want this length here. So we can just sketch out the two triangles we want. So there's one, and then there's the big one. For the small one, we know the length is 4. And for the big one, you have to be very careful. The length is not 6, it's actually 10. It's the whole length there. And then the base length is 7.5, but that's given to us in the question here. And we're looking for the small length. So again, we're going to go this way. To get from 10 to 4, you divide by 10, multiply by 4. So it's 4 over 10. The scale factor is 2 over 5. So that means we're going to multiply 7.5 by 2 over 5, and you get 3. And then that's your answer. Another example here, the diagram shows a square inside a triangle. So DEF is a straight line. What length is EF? So we want this bit here. So have a go. Work with your neighbor, maybe if you can see them in your garden or something, you can wave at them and just show them this question. Take a minute and then I'll go through it with you. Okay, so there's a clue in the question. I'm going to go through it now. The clue is the fact that this is 12, which means that's 12. So then you end up with a right angle triangle with a base 12 and a hypotenuse 15. You can then subsequently work out this length, which I have done here. So the length turns out to be 9. And then once you know the length of that small triangle, you can then scale it up to work out EF. So 15 over 9, so that ratio, 15 over 9, is equal to this length, which is it's meant to be, this length here, EF, over that length, which we know is 12 because it's a square. When you rearrange it by multiplying by 12, you get your answer. EF is 20. That was a bit of a challenge question here. Now, in terms of what you need to do, you can either skip ahead and do the next worksheet, or you can do 3 practice problems with me if you're not completely sure. So I'm going to do 3 practice problems, or the rest of you can just start the worksheet, which is explained at the end of the video. So just fast forward. So here's the first question. What is the length X? Have a go, pause the video, and then I'll go through it with you. Okay, so now I'm going to go through it. In this case, we have 2 triangles, the small one, which is 4 and 8, and then the big one, which is 5 and X. So the scale factor there, where we're multiplying by 5, dividing by 4, so it's 5 over 4, if you're going this direction. So times 5 over 4. So we're going to do the same thing with 8. 8 times 5 is 40. 40 divided by 4 is 10. So you should get 10 as your answer. Okay, second of 3 examples. What is the length of X? This time we're going backwards a bit. So I can see the big triangle is going to be 12 and 9. And the small triangle is going to be 8 and X. So this time the scale factor, to go from 12 to 8, you divide by 12, multiply by 8. So it's 8 over 12. And that just simplifies to, if I divide that by 4, it becomes 2 over 3. 2 over 3 is the scale factor. So then I do 9 times 2 over 3, so 18 over 3, which is 6. And then the third example, final example, have a go here, pause the video. Okay, now I'm going to go through the answers. I'm just going to sketch out the top triangle the right way around. You have to be really careful not to simply make that X and 7.5. Make sure you sketch them carefully so the corresponding sides match. So let me do the big one first, actually. So it's 10 and 15. Now, in this case, we have 7.5 and X. So the scale factor is going to be multiplied by 10, divide by 7.5. If you're going this way, but we want to go that way. So we're going to divide by 10 over 7.5. So 15 divided by 10 over 7.5. Now I could just change that into a multiplication and do multiplying by the reciprocal. So 15 times 7.5 divided by 10, I should get 11.25. And that's hopefully what you got as well. Now, in terms of work this week, you are going to do this exercise. Spend no more than 25 minutes on it. The last 3 questions are extension questions. I think I've written out the solutions quite well, so you hopefully should not get stuck. Don't get too stuck up on this final extension if you're not completely clear on it. However, the rest of it, including the first 2 extension questions, I think they're quite doable for you guys. Again, just to recap where we are, we have done congruence, we've done congruence proofs. We have now covered length, and then we're going to start looking at area and volume later on. So I'll see you after you have done this exercise on similar lengths.